So electrification is not a silver bullet, and let's discuss about it. So why? Why is it not? In recent years, there has been an increased requirement for innovation to address climate change concerns by reducing the greenhouse gas emissions. Many sectors have chosen electrification to achieve this, and this requires batteries to store energy. However, batteries are pretty heavy, hindering their usage in many applications such as aviation. For instance, the amount of energy that can be extracted from 1 kilogram of liquid fuels is at least 100 times more than that can be extracted from 1 kilogram of battery with the current technology. It has been estimated that it can take up to 30 years for the batteries to catch up. On the other hand, studies have claimed aviation can reduce its emissions by 65% using sustainable fuels. Therefore, in my research, we explore the path of using an engine along with biofuels and a controller to reduce the carbon emissions. However, there are three main challenges to this in this path. First, the combustion efficiency is severely affected by changing ambient conditions such as temperature and pressure. Second, the fuel properties of biofuels vary significantly. Third, many actuators are required to achieve reliable combustion. Therefore, to overcome these challenges, I work on developing control frameworks. So now, what do I mean by developing these control frameworks? Let's try to understand this through cakes. Who doesn't like cakes, right? Imagine you bake a cake and upon tasting it, you find out that it's not up to par. To improve it, you try to go back and change the oven settings or the ratio of the ingredients. Similarly, for an engine, the efficiency can be seen as the taste, and the control inputs such as the fuel injection timing or the temperature that can be set inside the engine cylinder as the recipe in the baking process. Perfecting the taste or improving the efficiency of the engine just by trial and error can be quite time consuming. Therefore, I work on developing systematic frameworks to reduce this trial and error and find these control inputs. So now, how do I do this? We first collect data points by running the engine at several combinations of inputs and ambient conditions, and then fit a model to this. Once we have this model, we search through this model to find out combination of inputs that can give a desired output. These combination of inputs are collectively referred to as feed-forward maps, and these feed-forward maps are stored by the controller to control the engine in real time. Therefore, to summarize, the main objective of my research is to develop control frameworks to achieve efficient combustion in an engine across varying ambient conditions with multiple actuators using biofuels. Thank you all for your time, and I'm Aswath.